Good morning, dear students. Welcome back to physics class. Today, I would like to present you a new topic which is work done by a constant force. In last class, you had studied there are two conditions to be satisfied in order for work to be done. Can you say what are the two conditions to be met in order for work to be done? They are: first one, a force should act on an object, and second one, the object must be displaced. For today class, you are going to study about how is work done by a constant force. Before that, you have to define work. For this, suppose a constant force F acts on an object. Let the object be displaced through a distance S in the direction of the applied force. Let W be the work done. We define work which is mathematically equal to the product of the force F and its displacement S. As shown in figure, the displacement B S by the application of force F. So, the work done W is equal to force into displacement, which is equal to F into S is equal to Fs. You have seen that work done by a force acting on an object is equal to the magnitude of the force multiplied by the distance moved by the object in the direction of the force. So, work is said to be done if force acted on a body displaces through a certain distance in direction of the applied force. This is the definition of work in physics. Work is a scalar quantity as it has only magnitude and no direction. Let force applied on a body is equal to 1 Newton and displacement by the body is equal to 1 meter. Then work done by the force will be equal to 1 Newton meter. Here this amount of work is done only if displacement is in same direction of the applied force. Otherwise, it will be lesser than 1 Newton meter. On next part, this detailed explanation is given. Here, the unit of work is 1 Newton meter, which is in SI system, which is equivalent to joule. That is, 1 Newton meter is equal to 1 joule. How can define 1 joule of work? 1 joule of work is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the applied force. That is, the object should be displaced in same direction of the applied force. For sake of understanding of its numerical calculation, now I give one example. Let be force of 5 Newton act on an object and 2 meter be the displacement taken place by the same object in the direction of the applied force. Then what should be the work done? If the force acts on the object all through the displacement, the work done W is equal to force into displacement, which is equal to 5 Newton into 2 meter is equal to 10 Newton meter, which is equal to 10 joule. Can you say what is the work done when the force on the object is equal to 0, and what would be the work done when the displacement of the object is equal to 0? As work done is equal to the product of magnitude of force and magnitude of displacement. If magnitude of force or the magnitude of displacement is equal to 0, work done will be equal to 0. This work done is said to be 0 work. The above mentioned points highlight the conditions in doing work. Now, I am going to discuss on different types of work. You should notice this point. Force acted on objects need not always displace them in its direction. How can give justification for this? Consider an example of doing this work. Throw a bucket of water from a well. Here, force is applied, which is the pull with the help of the rope. This pulling force is downward, but the bucket of water is moving in upward direction, which is opposite to the direction of the force applied. This means that work is done not always by force which displaces the objects in its direction once force acted on them. By this reason, work done is classified into three types. They are first one positive work, second one negative work, and third one zero work. First, I am going to talk about positive work. Work is said to be positive when force applied on an object displaces it in its direction or force applied is in the direction of motion of the object. In this kind of work, both the force and the displacement are in same direction. Let us consider this example. A baby pulling a toy car parallel to the ground as shown in the figure. The baby has exerted efforts in the direction of displacement of the toy car. In this situation, the work done will be equal to the product of the force and displacement. In such situation, the work done by the force is taken as positive. So, the work done W is equal to force into displacement is equal to F into S is equal to Fs, which is positive. Next one is negative work. Work is said to be negative when force applied on an object is opposite to direction of the object's motion. For example, consider a situation in which a ball is rolling on a floor with varying velocity along a particular direction as shown in given figure. The ball undergoes retardation or deceleration due to the frictional force exerted by the floor on the ball, which is acting in opposite direction to its motion, or both the directions of force and displacement are opposite to each other. That is, the angle between two directions is 180 degree, so the frictional force is retarding force. Let the object travels displacement S when it stops. In such a situation, the work done by the force F is taken as negative and denoted by the minus sign. So, the work done by the force W is equal to minus F into S, which is equal to minus Fs, or W is equal to F into minus S. However, both directions are always opposite. And last one is zero work. Work is said to be zero work when force and displacement are perpendicular to each other, or when either force or displacement is equal to zero. For example, when a coolie with a heavy load on his head walks on a horizontal road or railway platform, work done by his exerted force or work done by the force of gravity is equal to zero, because these two forces act perpendicular to the direction of the displacement of the load. The coolie exerts force in upward direction, but you know that gravitational force always acts in downward direction. In this case, work done is equal to zero, so work done is zero work as displacement acts in forward direction. Here, both directions, which are direction of the gravitational force or direction of the applied force by the coolie, is perpendicular to the direction of the displacement of the load. Let us go through an activity which you can do. Lift an object up. Work is done by the force exerted by you on the object. The object moves upwards. The force exerted by you is in the direction of the displacement. However, there is the force of gravity acting on the object. What is its direction? You know that it is in downward direction. Can you say about which one of these forces is doing positive work, which one is doing negative work? Positive work is done by your exerted force and negative work is done by the force of gravity. Can you solve this question? Question is, a porter lifts a luggage of 15 kg from ground and puts it on his head, 1.5 meter above the ground. Calculate the work done by him on the luggage. What should be its solution? Given that mass of the luggage m is equal to 15 kg and its displacement s is equal to 1.5 meter. We know that work done W is equal to force into displacement, which is equal to F into S, which is equal to mg into S, since F is equal to mg. By putting the values of m, g and s, which is equal to 15 kg into 10 meter per second square into 1.5 meter is equal to 225 kilogram meter per second square into meter is equal to 225 Newton meter. Since 1 Newton meter is equal to 1 joule, so this value will be equal to 225 joule. And also, you remember that 1 kilogram meter per second square is equal to 1 Newton, which you studied from the chapter Laws of Motion. So, work done is equal to 225 joules. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.